Hi, MC Bling Daddy here. This intro is a bit longish, so if you're already somewhat familiar with the idea of low and high level computer languages, skip to about 150 in this video. This is the first of a series of videos to introduce Minecraft players to a tool I've created for Minecraft, and I call it a coding engine. It's a follow-up for a series I did a while back called Command Block Coding. The intent there was to show how one could create programs for Minecraft based on code that resembled what you'd find in a modern high-level programming language, such as C#. As I'm sure you're aware, Minecraft has a command language you can use if you're an op that allows execution of single commands to do things like create blocks or affect players' attributes. And these can be strung together by using command blocks to execute multiple of these at a time. Although this is the natural format for automating events in Minecraft, these strings represent more what is called computer machine language, where single computer commands are defined and executed one at a time. Modern computer languages are designed to create blocks of low-level machine language output when fed to compilers based on simple descriptions of frequently used processes such as arithmetic computations, logic tests, or repeated operations such as in loops. The coding engine acts something like a compiler that converts condensed instructions into the multiple commands a computer executes. Unfortunately, Minecraft doesn't have such a feature to convert high-level language into commands for execution. The coding engine creates a series of command and other blocks that can be executed by powering up with redstone in an appropriate way, thus allowing repeated execution for automation of desired processes. Since these demonstrations are intended to show the viewer how things work in the engine, there are a lot of redstone repeaters involved to slow things down. This separates the command blocks that are used so that the individual steps can be seen more easily. So, let's see how you would go about setting up the engine and using it. The engine requires a fair amount of space, although it can be set up in totally blocked-in regions. For example, if you wanted to hide it, it's better to have some open space, not underwater or lava, to put it in. So, create a world, then find an open area. Here's a view that's fairly open. You could create it in a flat world if that's where you wanted to use it. Commands to create the engine can be executed one at a time, or, more quickly, by copy-paste to a server in which the world is running. If you use a server, start it up and log in as I have. Make sure there's only one player in the world so you only get one copy, or else change the first two commands to refer to a specific player before you paste into the server window. And best to make sure there is an open area to the north. That's where most of the engine and code blocks will be placed. The initial setup will appear mostly in the northeast. The first set of commands, about 80 of 600 total, can be found in the YouTube page you're looking at. Highlight them, then copy them from the page with Ctrl-C. Paste them into the server using your mouse with a right click. If a context menu pops up, select Paste. If nothing happens, left click on the upper left corner of the window where you see the command prompt icon. Choose Edit, Paste from the menu. All the commands should drop into the window and be processed by the server. If the last one is hanging on and not processed, press Enter to have the server execute it. If you have your server on a separate computer from the one you're running the Minecraft client on, the blocks that have been placed will appear, like this. Otherwise, whenever you switch windows for Minecraft, it always throws up a facade from which to switch back in, but the results are the same either way. And this is what is set up with the commands you've entered. There's space for additional command blocks on the right for the engine, and on the left is the start of the coding area. More space can be added as needed. The named minecarts that you see are used as reference points for putting blocks in the world. They anchor structures in the three main areas: engine, code, and the world in general. Each area has three sites or regions: the origin, O, row, R, like a line in a text processor, and cursor, C, to mark specific locations of current operations. So, WO, EO, and CO for world, engine, and code origins, for example. Be sure to escape and disconnect out of the client and stop the server after the world is created to save your changes. Okay, let's briefly note some useful info, then preview how the engine works. First, the engine is not complete yet. The description field of YouTube videos only holds 5,000 characters, so the engine comes in chunks that size for presentation. So don't move the ER, or engine row, minecart between videos, since it's used as an anchor for each succeeding input of commands. Second, the minecarts are easily jostled, so make sure your world is prepared, like for example with do mob spawning set false. You can set some of these in the server properties file, and they should carry through to the single player client. Check out the CBC, or command block coding, setup video for suggestions, or if you're curious why named minecarts are used. Third, you'll need to fly about one block higher to avoid hitting minecarts and knocking them around. Let's take a look at the first couple of items in the engine. The first one is actually a tool rather than a coding instrument. It's kind of like an enter or carriage return in a text processor by moving to a new row with a spacer. That's so command blocks don't end up side by side. If we look at the CR, or code row, while right-clicking on the startup button, we can see the code row move away from the CO, or code origin, and take the CC, or code cursor, with it. Next, let's put down some actual code. The engine is not actually a compiler. It acts more like a set of macros. Macros take parameters and generate code based on a preset template. Then Minecraft executes the commands that have been generated inside of command blocks. In the engine, parameters are to be entered inside command blocks that are indicated with signs. So for the command macro, we have to enter a Minecraft command inside the indicated command block. A right-click gets us inside the command block to see what's been pre-entered for this demonstration. It's assumed you know how to set up commands in Minecraft, so I'm not going to go into detail here, except to say that this command will set a gravel block where the WC, or world cursor, is. So let's check it out. Again, a right-click on the startup button will set the command block execution stream in motion, and we see command blocks and repeaters generated in the code area. One more command is needed for our purposes, so we'll use the second macro of the set, which has also been preset. This command moves the WC minecart up one, and it should end up sitting on the previously inserted gravel block. Alright, let's go look at our code. Here are the two command blocks that were created, and here are the commands that were generated. The first to set a gravel block, the second to raise WC one level. Now the thing about the engine is that it sets a repeater in front of each of the command blocks. So there is a repeater here under the CR. Although the repeater transmits a signal from command block to command block during execution, it also allows us to start the execution by placing a redstone torch before it. Let's do that. Now, note the WC in the distance and watch for a gravel block to be set, then the WC lifted one level. Well, the ultimate objective here is not to do everything manually, one step at a time, but to automate things. One way we can do that is with a loop. A simple loop can be accomplished with a set of repeaters going from the end back to the beginning to restart the actions within. And let's see what happens when we set it in motion. Unfortunately, this is what we call an infinite loop because there is nothing to stop it and it repeats indefinitely, or to infinity. We have to break a step in the loop for it to stop. Okay, that's a look at what's to come. Next time we'll check out setting up reference points in our code and use them to transfer among segments of code with more control. Please join me. Thanks for watching.